Hello, beloved VFX community, or whoever else is watching this video. Today, I am going to teach you how to make it so that your velocity aligned particles slowly start to face the camera again once they start to slow down. I noticed that a lot of VFX artists don't understand how to do a cross product, or even worse, don't understand the axis system in Unreal Engine. But let me start with the basics. What is a cross product? Say we have two vectors, and I know this sucks that I'm explaining this thing, but I'm gonna do it quick. Say we have two vectors, like so. We have to know that the axis system in Unreal Engine is left-handed. So we take our left hand and we put it on the table. Put your elbow on the table, and there it is. If we cross from this vector to that vector, so we have our hand. If we close our hand, we basically pull this vector to that vector, and that means now our thumb is pointing in that direction. So we basically find a vector that is perpendicular to both vectors. So you could imagine if we take the cross product from this vector to that vector, we have to put our hand down, like so. Very beautiful looking hand. And then we take the shortest path. Again, we always have to take the shortest path, but always left-handed. In Blender, Unity, Maya, Houdini, it is all right-handed Y up. But Unreal Engine is left-handed Z up. And that's always why we have to rotate, if it's a character or anything, on the x-axis by -90 degrees. That is actually the reason why. So now we understand that thing. Amazing. Okay, good. So if we take the cross product, now it's perpendicular, but pointing in the opposite way. Good, we understand. Let's go to the module. Now it's gonna become fun. First of all, if we go to the sprite renderer, and if we set it to velocity aligned, now we get back to this problem that we have, We're trying to make it so that the particles face the camera. Okay, we can use custom aligned instead. And then if we go in the module, ignore everything. But if we take the velocity vector and feed it into the sprite alignment, we are back to where we were trying to fix this problem. But now the good thing is we have control over this vector. And that's why I am here applying a few calculations. So let me hook it back up and start explaining you the solution. Now, what we want to do, let me just delete everything. Say we're in a top-down perspective. Wow, that is a horrible camera. And say we have a sprite being pushed up like that. It is stretched, why not? So then what we want to do once it starts to slow down, because it's pointing this way, but once it starts to slow down, we want it to point towards the camera. So that means, first of all, what we have to do is find the camera direction from the camera position to the particle position. So that's what I'm doing in this custom HLSL node. I'm grabbing the view world view origin, and then I'm converting it from large world coordinates to float 3 values. Similar to, when you take a position and you convert it to a vector. And then if you see, I'm basically taking that position, and then I'm taking the direction from the camera position towards the particle position by subtracting both and then normalizing it. And then position is basically this particle position. And then we make sure that it's converted from simulation to world space. So we make sure that the values we get are in world space, basically. That is what it's doing. We don't use local, because if it's local, it assumes that it's already local. But it could be that your emitter is not in local, and then your values get messed up. So we put it in simulation, and simulation will detect whether your emitter is already, in world or local. That is the thing. Okay, and then we find the direction. Now there's an extra cool thing I want to show you. is that you can also use the view forward, but the problem with it is it's not taking the direction from the camera to the particle, but just taking the camera direction vector. So it is not really helping us solve the problem. So we don't use this one. Instead, we have to use that one. Okay, good. So now we know the direction vector. And then if we take the cross product with our particle vector, they are a bit close to each other. I know it's annoying, and it will start to become annoying to explain. Maybe what I can do is just push them away from each other a little bit, like so, that we assume that. And then what we want to do is take the cross product to find the side vector. I'm not sure if it's in the correct direction. And let me see, actually. So we take the cross product in this case. For the first vector, it doesn't matter too much which inputs you set, but in the second one, it will become important, and you'll see in a minute. Okay, so in this case, I'm taking the velocity vector. Okay, so we take the velocity vector, put this one, and we do the cross product towards the camera direction. So if our hand is here, like so, we close this one to that one, and now, yeah, you see, this vector is supposed to be in this direction. Okay. So that means if we would have crossed this from that one, it will be in that way. Yeah. Okay. But yeah, it could be that you could work with any, but now it's important that the second cross product will basically result in a vector, so our velocity vector that is projected to our camera plane. This is our camera plane, yeah? It's a flat plane, and we want to basically project this vector to the flat plane. You see, imagine this one is projected, yeah? That's what we're trying to do. Now it becomes important, okay, if we take another cross product, say we put our hand down, yeah, because our thumb is pointing in this way, yeah, because we want the vector to point in that way. If we put our hand down, now we take the cross product from this vector to our newly created vector, you see, because if we would cross from our newly created vector to that one, now our thumb would be pointing downwards, but we want this vector to be projected and like point that way. So we know that we have to take the cross product from this one to that one. But you can imagine if your first cross product was was wiggled, then you could imagine, oh yeah, now I have to wiggle the other inputs as well. That is the thing. But in any case, this is why it's so important, because sometimes I notice VFX artists, they like negate it, and then they like, oh yeah, we have to wiggle the inputs, and then they are trying to wiggle their way through. And you see, this will also work. But if you understand the axis system, you will be able to do a lot with Niagara module scripts, and I mean a lot. And there it is. We have basically projected that vector. So you could also use projection math. There is, I think, yeah, you can use the modules, or you can just do the math yourself. It's quite easy actually. But there's many ways of doing it, and projection math could maybe even be cheaper. In any case, I don't recall if I actually told you that we have to normalize this vector, but this one we don't, and simply because our output vector doesn't really need to be unit anymore. We already just directly feed it into our sprite alignment, and we're not using the data any further, so we don't need it to be a unit vector anymore. But whatever. Now, what I do, I lerp with, if I check, I have my direction and my length, so my velocity speed. And now I'm subtracting with a value and dividing, and then I'm clamping it, and then I'm using that as an interpolator. And I will explain you. To interpolate from our velocity vector towards our projected vector, so our camera vector. Okay, cool. So let me see. here it is. So say the camera threshold is when it should start in. Say when the velocity of the particle is at speed 50. And then I can say how long or how fast it will interplay. So stay at speed 5. So that means from 50 to 55, it will blend. So if we look at it, see? Okay, cool. So if it would be at much greater speed, it will kick in faster. So let me show you. See, it's kicking in a lot faster. So if I slow it down, it kicks in a lot slower. And then, sooner, sooner, not slower, sooner. And this other value is how fast it should kick in. So if I put it to a greater value, you'll see that it's taking a bit more time. And that's why this can be so useful if you have like lingering particles that burst out and you want them to be aligned, and then you have some curl noise, but you don't, the curl noise is making the particles, you know, always point in a specific way. Like I can show you, like this problem, we can solve it. We can really solve it. So if I just put it back to velocity aligned, like so, yeah, you can see, you see that issue, it really sucks, right? See? And it makes a lot more sense once I start playing with these values. See, there it is. So that means now if I use my custom aligned, you can already see it's starting to face the camera, and that is the problem here we're trying to solve. So let me show you, camera facing, and yeah, let's say let's speed this, voila. Now see it's facing the camera. It's pretty cool, right? And then what you could do is at a certain threshold also ignore velocity. Now we could also do that, or just use you store the value, your velocity, and then you store it as a last frame velocity, and then once this thing kicks in, so you could check with like if it's greater than, yeah, you could then say, oh, okay, it's below that, oh, just take the velocity from the last frame, you know, and then it will also not be rotating anymore. But in any case, I'm gonna fine-tune this module and I'm gonna put it online on Gumroad so you can download it. Please leave a review, like, a comment, and yeah, support me, because I'm putting in a lot of effort to do these type of tutorials and I like to share. But yeah, it comes with a cost, of course. But this one is completely free, and what I'm actually doing is I'm trying to promote my game Drone Tanks, and I'm also trying to build a community. So everyone, feel free to join the Discord, and I will always keep sharing more super interesting tricks that can really set you off as a VFX artist. Otherwise, thank you for watching, and I'll see you in the next one. Peace and love. Bye.